In this question, we're asked to determine the pH given a concentration of H3O plus and determine the concentration of H3O plus given a pH. And so we need to know how to do these two things. The first thing to remember is that pH equals the negative log of the concentration of H3O plus. If you look at acid-base chemistry, you'll notice that the concentrations of H3O plus tend to be very small molarities. And since these are such small molarities, it's easier to look at the exponent than it is to look at the whole number. So for example, if the concentration of H3O plus is 1 times 10 to the minus 7, then the pH equals 7. If this concentration of H3O plus goes up to 1 times 10 to the minus 6, the pH will equal 6. So pH makes these numbers easier to interpret. But what's important to remember, one, of course, is the formula. But secondarily, what's important to remember that as we transition from a pH 7 to a pH 6, the concentration hasn't gone up a little bit, it's gone up by 10 times. And if we went from pH 7 to, say, pH 5, which would be H3O plus, these are the concentrations of H3O plus, these would be 1 times 10 to the minus 5, that would give us a pH of 5. Notice that this is 100 times more concentrated than this. And if you went down to pH 4, it'd be 1,000, then 10,000, so on and so forth. So the pH scale, essentially, we're looking at the exponent instead of looking at the actual number because it's log base 10. And this is how we actually calculate it. The next thing I want to talk about is, well, what do we do if we're given the pH? Well, and if we're given the pH, we need to rearrange this equation. First, I want to get rid of the negative, so I'm going to multiply both sides by negative 1. Negative negative becomes positive, and I guess probably better to write it that way. Multiply this by negative 1. So we get the negative pH equals the log of the concentration of H3O plus. To get rid of the log, we take 10 to the power. So we take 10 to the negative pH equals 10 to the log H3O plus. 10 to the log, base 10, cancels out the log. So I'm just going to move it to the other side. Concentration of H3O plus equals 10 to the negative pH. So I'm going to get rid of these so it's easier to see. But essentially, we need these two formulas. pH equals negative log concentration of H3O plus, and concentration H3O plus equals 10 to the negative pH. If you don't know how to convert from one to the other, you don't need to memorize that, as long as you have both of these equations in your mind. So now I want to actually do this, and I want to show you how to do it on the calculator, and I also want to talk about significant figures because they're a little bit weird with pH. So here we're given the H3O plus. So in this case we want to use this one. pH equals the negative log of 8 times 10 to the minus 8 molar. Now, if this is a 1 out here, you don't actually have to do this. You can just do it in your head because if you notice, 1 times 10 to the minus 7, the pH is 7. However, if it's an 8 out here, I would recommend using the calculator to do this. And I do want to show you how to do that. So I'm first going to use just the same two as in the previous video, popular brands of calculators, because they happen to be what I have available to me. And I want to show you how to type in this number. So on a Calcio calculator, we first hit the log button, and then we type in 8, 10 to the x, negative 8. And then you can, or you don't have to, close the parentheses and press the equal sign. And you'll notice that it says negative 7.09. Now, it's not impossible for a pH to be negative, but with concentrations like this, it's not going to be negative. So don't forget, it's the negative log. So we'd have to multiply that by negative 1, which if you want to, you could just do times negative 1 and then get the positive answer. Alternatively, you can just ignore the negative sign. It's probably easier. But that's basically that. Note that because we're in log space, this 7 represents the exponent. And why that's important is it is not a sig fig. Just like this exponent is not a sig fig, or the leading zeros here, the 7 zeros before you get to this 8, are not significant figures. This 7 is not a sig fig. So the first sig fig is this 0. Since this has one significant figure and we want this to have one significant figure, the answer is 7.1 for the pH here. Let me show you how to do that on a Texas Instruments brand calculator. It's basically the same, but I do want to show you both calculators because these are two of the more popular ones. All right, and if you don't have this exact Texas Instruments calculator or this exact Casio calculator, chances are the Casio or Texas Instruments calculator you have works similarly, although they're not all the same, unfortunately. Older ones don't work always the same, but that's just the way it is. So let's look at how to do this. We want to again type in the negative log of 8 times 10 to the minus 8. So we type in log 8 second EE minus 8. So on the Texas Instruments, just like when we did in the previous video, the E key gives you the times 10 to the power. So the EE is basically this. And you just put one E on the screen even though you hit the EE key here. Note, to get to the blue one on this calculator, you do hit the second button. So these blue ones are under the second button. So that's basically how it works. Again, you could close the parentheses or not. You hit enter. You can multiply by -1 or not, it doesn't matter, but just make sure you read it as a positive number. And again, because of significant figures reasons, this 7 is not significant, so the first sig fig is going to be that one, so we get 7.1. Let's look at the next one. In the next case, we're given the pH. So we want to find H3O plus, and therefore we need to do this, 10 to the negative pH. So concentration of H3O plus equals 10 to the negative pH, which in this case is -2.5. Note that because this is a pH, it only has one significant figure. So we need to be aware of the fact that this is only one sig fig. The 2 doesn't count as a significant figure. I want to show you again how to do that on two popular brands of calculators, the same two. Okay, starting with the Casio again. In this case, we want to do 10 to the -2.5. The 10 to the x button is the second log, so it's above the log. So we hit shift on the Casio, not second, and we hit 10. And now we want to put in -2.5. It's super important that it's negative, so we put in -2.5. We hit enter. We get 3 times 10 to the -3. Remember, and that's molar, remember that this is only one sig fig. The first digit of the pH does not count in significant figures. And if the pH was 11, in the first two digits, the ones before the decimal point do not count as significant figures. Those are placeholders. Those are those 2 zeros before you get to the 3. So that's basically where we are. So it's 3 times 10 to the -3 molar. I want to again show you how to do that on a Texas Instruments calculator, and it's very similar to how you do it on a Casio calculator. But in this case, the log button is here. We hit second instead of shift. We hit log. And again, it's very important that we put in it as negative. So we put -2.5. You can close parentheses or not. And this is the number you get. You'll notice that the Texas Instrument calculator didn't automatically put it into scientific notation. Some do, some don't. So basically, we need to convert this. So we move the decimal place 1, 2, 3 times, and we get 3 times 10 to the -3. For the last one, we're given the concentration of H3O plus, so we want to take the negative log of this concentration. But if you'll notice here, this is a 1. If this is a 1, then it's just the exponent. So here, the pH is 9.0. Note, the 9 does not count as a significant figure. So therefore, since this has one sig fig, this 0 is the first sig fig. Notice the only reason I could do this without doing the actual math is because this is a 1. So if this is a 1, then when you take the log of it, you're just going to simply get the exponent. And then when you'll get -9, and then you multiply the -9 by -1, and you get 9. But we put 9.0 because one sig fig, and this is the first sig fig. In a pH scale, this is not a significant figure. So there's kind of a lot going on here, but these are relatively straightforward calculations. And if you practice a few, you should be all set.